Now, normally what we used to do is we would do the labs, and we would be on these in the back, and you can see I need to take it off there. Some of our trainers say reserved for sensors, reserved for sensors. That's before we started buying the devices to move over to the blue trainers. The problem we have with the blue trainers is there's absolutely no 120 volt plugs over on the side over there.
None?
None. But it makes no difference. Why does it make no difference? Well, we've got a 120 volt transformer. We got a transformer that steps down from 240 to 120 around that, right? You understand? So all our other sensors are rated at somewhere between 120 or so volts. The temperature sensor is strictly 24 volts DC, period. Okay. So what I've done, and I was doing that this morning for this class, by the way, the power supply that the 24 volt DC power supply is non-polarized. What does that mean, non-polarized? They don't care about neutral and they don't care about hot, right? Understand that. So that means if you look at the blades on that, they're both the same size. Yeah. So what we do on single phase, if we're using double insulated devices, this pops up, guys. So this is polarized. So this is considered what electricians call hot. This is the blade that's supposed to be going to neutral, right? You understand that? So on ours, this would be L1 and this would be L2. Ours really don't make any difference because we're not referencing ours to ground. We probably need to do that. I need to add that. So what I've done, well, we've got a transformer up there, and what does that transformer do for us? Step it down, 240 to 120 or there. It's usually around 117, 110, something like that. We don't have 240. We have. So what we've done is, or what I've done, is just built these guys right here. So this is a standard one. This is a standard 150 volt plug, right? Understand? And then I come up through here on the other side, and there's a piece of heat shrink on here, and I'm going from here to here. So what can you do? Just plug them into a slot, 120 volt slot, and then you can plug the power. So all your trainers now can run the power supplies, right? That makes sense. So everybody should have one of these on their desk over there. Until you get to them, you can hang them up or put them in the drawer. So this gives us 120, so we can plug without having a 120 volt plug on the wall. That makes sense? Okay.
It's going to be okay for us to have two slots in the transformer?
No. Yes, you do.
Okay, I misunderstood. Where are you going to plug that?
You're going to plug that power supply. You're going to plug it into somewhere down your line. You've got a jumper that's only got one plug in there. Down the L1 or L2 side, right? You understand? So I've got L1 and L2, and then we start jumping down here. And guys, you don't have to jump, but I got L1 and L2, right? You understand? And I come over here. How many I have right there? I have one. I jump to that one, jump to that one, jump to that one. Well, but down here on this guy right here, I only got one. I got one. So what can I plug in there? I can plug in this guy. And also on this one, we're doing the same thing over here. We're jumping down here, we're jumping down here. And the last one down the line is still going to only have what? It's going to have one in there. So no, we don't have, all you do is just plug it in at the end of the line. Well, what we're doing is we're plugging this guy in here, right here on the bottom one. And then over here, this is giving us, we got 120 over here. And then we plug in our power supply, and then we're going to have 24 volts to plug into the power plug on the. Yeah, so if you look at the power supply, L1, L2 don't make any difference. Now what I've got here is the black one. I didn't have a red, unfortunately, guys. All I had was yellow and black. So this is wired to the neutral side, and this is wired to the L2 side. So y'all need to still honor that, even though the power supplies themselves don't care. So the power supplies that we have are non-polarized, which means you can plug them in this way or you can plug them in that way, right? If it was polarized, you'd have to put the big blade toward the big and the small one. But the power supplies themselves are non-polarized.
You said yellow was going into L2.
No, the yellow one's L1 and the black is L2. The black makes sense. Yeah, the black makes sense because usually we use black for common engine, and that's why
I asked you.
But I didn't think about white. We might have some white ones back there. I just picked yellow, but white would be the same color code that we use over here for neutral and hot. So over here, the color code, residential wiring, commercial wiring, there's really no fixed color code for there. There's usually color codes available, but if you ever get out in industry, mostly if you get inside their relay cabinets and stuff, they use the same color wire. And then they label it. And why do they do that? Because now they don't have to keep a spool of green and a spool of yellow and a spool of red, right? They just use all the same color wire. Out at US Steel, they love black wire. It was all over. So the plug itself is non-polarized. So when you plug it in, what can you do? Well, you can plug it in pointing this way, or you can plug it in pointing that way. It don't make any difference. And if you need to charge your cell phone when you're over there, you can plug that into it. So now we got but you keep turning it off right while you're waiting. So here's our sensor. So let's try to figure this thing out. So what they do is, and unfortunately, guys, they do this. They kind of simulate this. Is what they do is we have an upper limit and we have a lower limit. So this guy here has a span to it. And so what you do with the two bands is, you notice you got two adjustments. Oops, that's what I was right where I wanted it to be. So we got two adjustments here. We can lock it down. So we can lock it and unlock it. And then once we unlock it, then we should be able to turn the bands, right? Okay, so this is unlocked. And then we come in and we set, we have, I'd have to figure it out. This is set, this is reset. So this is your upper limit up here, if I can get this thing to focus in. But y'all can read it, right? So the bottom one's labeled what? Reset, the top one. So this would be the bottom temperature that you want it to trip out at. This would be the top temperature you have to see. So what you're doing is you're setting the span. If you wanted to set it to trip at one temperature, then you'd set both of the bands to the same value, right? This is a sensing element. This is probably an RDT, guys. I'm not really sure, just the shape of it. Then this is where we're going to plug in our power supply right here. This is focused. This is where we're going to plug our 24-volt power supply in right here. Now what they're doing is we're having to go from 24 volts DC outputs over to 120 volts for our other relays, right? You understand? So they call this an interface, and all it is just a control relay. So on this, the coil is rated at 120 volts, but across the contact, we can put 240, right? I mean, I'm sorry, 120 or even 240. Does that make sense? Everybody okay? Yes or no? And it's a 4-wire sensor. And so if you look, we should see black, blue, white, and brown. So what's brown? No, black signal. Black and white's the signal. It's just the black is a normally open. No matter how they do it, the black, they're probably doing it with a transistor or something, but we treat the black like it's a normally open contact, and then the white is a normally closed contact. So they're bringing both those out, right? You see that? One of them goes, the white goes to this relay, and then the black goes to this relay.
You said brown is positive.
So brown is what? Positive. Blue is negative. Black is signal. But it's going to be a normally open signal, right? You understand? So it simulates a normally open contact. And then white simulates a normally closed contact. Now I'm saying simulate because odds are this guy here has no real contacts in it. It's going to use a solid state device like a transistor to either turn those on and turn them off, right? You understand? We okay? So what we're going to have to do, guys, is we'll see if we'll look and see if this is covered in that booklet that I gave you. But if not, we can figure this out. So I don't know how many poles this thing has, but they're only using one of the poles coming out. We'll have to figure out which one's common and which one is what, open or closed. So, but these guys here should operate opposite of each other. So when this guy's energized, this guy should be what? De-energized. And then when this guy is de-energized, this guy here should be energized. But we really don't need that unless we need multiple contacts, right? You understand? I don't know how many contacts the lab calls for, and I don't know if they're using all the contacts. We'll have to figure out which is common up here, and we'll see if we can see if that's in the data. So what they're doing is they're bringing the output of the digital sensor, and then they're doing what? Going to relays, and what are they using the relays for? Not the power, the voltage, right? It allows us, instead of switching 24 volts, we're switching what? 120. That makes sense? And you'll see this a lot out there. Because my PLC, it likes to use 24 volts DC. A lot of my control relays like to use 120 volts relay, right? So we run these through a little control relay with a 24 volt coil, and then we can use whatever we need to on the contact. Are we okay? Let's see if we can find this. Let's see if this temperature sensor is. By the way, we were over in the hall building yesterday afternoon, and the fluorescent lights started humming. They started going off. Power fell and came back on. Power fell, came back on. Some lights worked, some lights didn't. They used 3-phase power over there. So what was happening? It looked like as they were having problems with one of the phases. So they cut the power out in the building completely. And I don't know if it's back on now, but they was over there working on it. So luckily I brought our backup drive over here. So I still have access to all our PowerPoint. Because I was thinking about what I was going to do. So this is I'm looking to see if they give us the actual pinout on the relays, or we have to figure it out. Seems like last class we had to figure it out, but I just made one change. guys, it's not bringing up my components. This main PowerPoint right here. Huh? Oh, here we go. Finally came up. Now I'll probably get two of them up. So what we're doing is we're looking for the temperature sensor. And we know this guy here is not quite correct. The programmable timer they show in here is not the same programmable timer that we have. And the motor's not exactly the same, but no, this is the one we have, yeah. And we don't have the programmable relay. This is our programmable timer is different. And with drum switch, we have that. Control relay, we have that. That's the same one that we have. Three phase. No, so none of these are in there. So we do have the data sheet on Blackboard for the actual. Oh, dang it, Rich! I'm trying to get to our server instead of coming up here. So I pulled our backup drive off there. So all these data sheets should be out there for us. So how are you going to determine the contacts on the relays? Yeah, good job. Exactly right. So we should be able to find the normally open and normally closed contact. I'm not sure we have to use both of these, but remember, these guys are always going to be, they're going to be opposite of each other, right? Because this guy here runs off the normally open. This guy here runs on the normally closed output of our sensor. So if I needed two normally open contacts, then I'd use the normally open here. Oh, I'm sorry. It's for us. Can y'all see this? Can y'all see it on your diagram? I didn't see that. I thought it was numbered, but it's not numbered. What is it? C, right? So this is common. This is normally open. This would be normally closed for the black wire. This would be normally open and normally closed for the white wire. Right? You understand that? So if I needed two normally open contacts, I would use the normally open here, and I would use the normally closed over there, right? You understand that? Because this guy is always going to be what? Opposite of that one. That makes sense? So that's on there for y'all. I thought this was numbered 1, 2, 3, 4, 5. But when we look, what we're going to have to do, guys, is you're going to have to go down to the cafeteria, and you're going to have to get some ice water, right? And that's what we're going to do. We're going to dip this thing in ice water. We're going to set it and see where it trips. Then we're going to take it out and see when it trips coming back, right? And I think we use hot water. There's hot water in the bathroom, though. So we'll have to get a cup. Y'all have to get a cup from downstairs, right? And then probably 2 cups. Put white in one, ice in one, and then we'll go down to the men's room down here and get the hot water. So this is our sensor. So this guy will only operate between 9.6 and 32, so that's why we can't run it off 120 volts, right? And it needs what? Yeah, DC, yeah. This gives us the current consumption, so this guy here is going to pull about 30 milliamps to work. The output rating, this guy gives us it can only drive something that's up to a half an amp. So we couldn't run a motor with this thing, but we could take this thing and pull in a control relay, and then the control relay might not run the motor, but then that control relay can pull in another relay, right? We called them stages. So out at US Steel, we had these little remote controls, and they were running 200 or 300 horsepower motors on these big cranes. Well, if you ever went up to the radio system, it would pick up a little peanut relay, and then it picked up what we call an intermediate relay, and then the intermediate relay picked up the actual relay that ran the motor. So you're running there a lot where you have to go through stages to get the amount of power to pull in those big old relays that sure enough run some big motors, right? I'm trying to see where it shows us the set 1, set 2. The one we had says what? Set and reset. Yeah.
What are we gonna set these? It's kind of hard. Not really.
I don't know what you mean we're going to set them. We're going to put them on that wall. We're going to put it down low enough so I can take a cup and put it up.
We're gonna set it about 75.
Well, you're going to do what the lab tells you to do. Yeah. So they're going to tell you what to set it, and then they're going to say put it in cold water, put it in warm water, right? And it's going to tell you, the lab tells you where to set it at. That's a good question. You haven't seen the lab yet. These use 2 PNP transistors. So there it is right there, guys. So what's PNP? Yeah, these guys here are source. So we call them normally open and normally closed contact. These solid state sensors, they don't use, most of them don't use relays. They either use NP in or PNP outputs. From our standpoint of view, it acts like, so PNPs act like a normally open contact that's connected to L1. Right? And L1 is positive, right? You understand that? So these guys are sourcing sensors. So that's the way they're going to label these things, these solid state sensors. And we could have went back and looked at the photoelectric sensor too. I'm sorry, the photoelectric sensor that we have, it runs off 120 volts AC. So it probably uses what we call a triac output, which is basically a solid state relay. So this shows us our connection, and I don't know if it shows us how to so it uses a thermocouple. So it don't use an RDC, that's actually what? Thermocouple. And undoubtedly, depending on the version that you get, it tell you what it is. Can y'all see the part number on this thing? Should start off with like a TMK. Yeah, every one of them, it looks like when you look at the sheet down here, every one of them is, oh, I'm sorry. If it starts off with RD, if it starts off with RTD, then it uses a what? It uses a resistive temperature device, right? If it starts off with T, then it uses a what? Thermocouple. Can y'all see what ours starts with? What's that? So it does start with a T. So ours uses what? Yeah, so ours uses thermocouple. And then depending on this model, they don't tell us what type of thermocouple it is that I saw, but this will give you the range that the temperature sensor is designed to have. I imagine ours would be down in the low range, right? Like PDP 25C or anything like that. I don't think we need to go above 300 degrees Fahrenheit. I don't know, it might go negative too, so it might be one of these other ones over here. We would have to look at the actual part number, but that's okay. Locking ring, everybody okay on the locking ring? So it's the little ring on the top. So this is the way you can lock it down, prevent people from it accidentally being moved by vibration or something like that. So you got a locking ring for both the top and the bottom.
As stiff as it is, I don't think I could move it.
Well,
I mean, I've said it, okay, all right, yeah, but it's pretty stiff.
well, when you lock it down, yeah. When you unlock it, it's not. When you unlock it, it's not too bad.
Well, mine is. Well, it's not too bad.
Yeah. And then when you lock it down, it ain't
going over.
Yeah. So we okay? So let's look at the lab real quick. The first part of the lab. I gotta remember not to go to these drives over here because our server's down over there. So this tells you differential gauge. It gives you a pretty good write-up on this inside the actual lab itself. So ours is not going to be like this, right? So we're going to have to, this is not exactly the way ours is going to go. So how we're going to have to modify this? So this is not exactly true. You understand what I'm saying? Yes or no?
Well, yeah, we've got it.
We're going through a relay, but the relay we're going to treat like this. Everybody understand that? Okay. So technically, if we was to draw this out, the temperature sensor would pick up a control relay. So technically, the way this would be drawn is we would have basically two different control circuits. And you can see, so technically the way we would have this is we would come over here and we would have two different control circuits. One of them would be 24 volts DC, and this would be L1 and L2. Right? Understand that? And of course, this is what we're going to do is we're going to come over here, and this is where our plug-in cord is going to be at. I mean, our power supply. Sorry. And then it comes out on the circuit board, it has an L1 and L2, right? And then our temperature sensor is actually powered up all the time. So we'd come over here, we'd have our temperature sensor. And this would be one of them, right? Y'all understand that? And then I would come over and try to do this. I've run out of room. Then I come over to do that, and then we come over here, and then we're going to go to the control relay. And then this right over here is going to go over to that right there. So this is technically what we got, right? And then we would have another wire coming out this side, and this goes to another control relay. And this right here would be the normally closed. Normally open. This would be the what? Normally closed. So this would be brown, this would be blue, this would be black, and then this right here would be white. And then what we would do, we call maybe this would be CR1, this would be CR2. They're calling them K1 and K2, which is pretty standard for relays. We call them K. So this would be K1, this would be K2. And that would be one of, and then we would come over here in our 120 volt line diagram, right? You understand? And then technically this would be K1, whatever it does, and this would be K2. And over here, this L1 and L2 over here would actually be what we're calling 120 volts AC. Now this is really the way it's wired up. You understand that? Well, they're something. They could be relays, whatever we're trying to control. So it might be a motor starter. When it gets up above the temperature, we turn on the fan, right? When it gets below the temperature, we turn it off. Huh? This is this right here. Okay, I understand. And now we got two contacts available. So actually on this guy, we got a what? We got a normally open and we got a normally closed. Down here, we got a what? Normally open and normally closed. Over here, I don't know. I don't think we'd have to look at the diagram to see which one they're using. Right? You understand that? Now this is technically the way they are, but the way the diagrams are drawing is they're using this. They're using the symbol. They're using the symbol for the temperature sensor for a normally open contact over there. So that's the way our diagrams are drawn. With the actual real life, we're going to have to hook up the power supply to the what? To the temperature sensor. The temperature sensor is over on this guy, and then it's going to pick up K1 or K2, and then we're going to have K1, K2 contacts over in our diagram. So what they're not doing in the lab is they're not showing the what? They're not showing this on the left because you're not doing anything on that. This is technically already wired for you. You don't have to wire this, right? This is wired. Okay? This is wired on the sensor itself, right? You understand that? So when you look at it, you're looking at it from this point of view over here. So in the wiring diagrams, what you're going to do is you're going to use those relays just like they're the what? The temperature sensors. Now, how many do you need? Well, here you got one, you got two, right? You understand? These guys are connected together. So you don't have to use both relays because notice this guy right here has got a common point. Right? You understand that? So what I would do, and I can't remember how to draw on this thing, guys. Let's look up. Some shortcut keys. But this right here would be our common. So what we're going to do is, we're not going to worry about this guy on the left-hand side. That's done for us. But if I was going to have to wire it up in real life, then that's what we would have to do, right? To go from a 24-volt sensor over to a 120-volt circuit. So what you notice on this thing, and I'm not going to draw the whole diagram. I don't know what they're turning on. But up here, they got a what? They got a normally open temperature sensor. Down here, they got a what? They got a normally closed temperature sensor. Now notice right here we have a what? We have a common. Right? You understand that? Yes or no? And it's built in there for you. So basically all you got to do is just bring L1 down to the C, right? And then use, then figure out, then then here use the what? Normally open, and here use the normally closed. So you don't have to use both relays. You can get both of those off of one because why? Yeah, because you got this comma. If I needed to use a normally open over here and I needed to use a normally closed over here, then we could do that. What's nice on this one is both of them are hooked up. We've got a reference. Y'all understand what I'm saying? Yeah. So if I was to run into a situation where I came over and had this, so I had a normally open temperature sensor, and then I came over next door, and then for some reason I had a what? Normally closed, then I would have to use the two different relays because there's no what? There's no common connection. But over here, all you have to do is just take L1 and hook it to the what? Common. And then over here, wherever this goes, then you would hook this up to whatever load you have over here. I don't know what it is. I don't look at it. And you'd hook that over to your load over there. Everybody okay? And what are we using? I think on the first lab, the one that y'all going to be required to use to do, I think all we're doing is just turning on a red and green light. So this will be our normally open output. This will be our normally closed output. And this right here will be our common. So this is going to be a very, very simple circuit. This is the one I want to make sure that everybody does. So what we're going to do is we're going to do the first lab. No matter where you're at, when you get through to the lab, I don't want you to tear the lab you got up now, right? But if you're ready to go to the next lab, then I want you to go to the next one. I want you to do is the first what? Level control. Then the next one I want you to do is the first temperature control. And then come back and do what? Then start working on true gray. Well, I'll see how that works out as far as the scale goes. And guys, what you need to do every year, every year we have to do what we call SLOs. These are what we call student learner output, student learner outcomes. And so we set goals. Well, this is one of our student learner outcomes. This is required for our program, and this is required for accreditation. One of the things that is required is that all these chapter quizzes have to be turned in. Right? You understand that? So even if you don't get in, if you look at it, lab 3 has the chapter quiz back there. So even if you don't get through with all of the, the proximity labs, even if you don't get through with all of the temperature labs, even if you don't get through with all of the level control labs, you are required to turn in those quizzes. Right? You understand? And of course, those quizzes can be done without actually having to do the lab, or you should be able to figure out without doing the lab, right? You understand? Most of the information is in the discussion section of the lab or in the supplement part of the lab, right? Just about every one of those answers can be found in there. So no matter how far you get, all of those are going to be required to be turned in next Thursday, right? Now, what we'll do, so we're running it, we got one more week, full classes, right? And then the next week is the what? Final exam. So what we'll do on that day is we'll let y'all come to lab. So what we'll do on the final exam day is, what do y'all want to do? Y'all want to do lab first or the final exam first? It's your call. Because y'all are really way behind in lab. So we're going to have to have a day, right? Even on final. Normally we don't do labs or anything but this semester is kind of different in that our semester actually ends on Wednesday, and my grades are not due till the next Monday. We had those 2 weeks, but y'all took the 2 weeks when? 1 week when we was trying to get our MSSC certification, and then so the other people won't get out until the end of that week, and they'll get out the start of the week. Are we okay?
The final exam this time,
We haven't put it, and usually we always finish.
Yeah, always, I give y'all.
But that could be the last, whatever that time is.
Well, what's nice about taking it at the end is that if you take it at the end, then if you get through early, you can go. If we take it at the beginning, if you get through early, then you can take a break. So, but what, if we take it early, what we can do is we can open the lab, we can either open the lab at the time or we can open it when everybody gets through.
That's
But it's,
key right there. It really don't matter because you're not going to open it till everybody gets through.
well, normally everybody gets through before the time is over.
So what you're saying is we could have a little bit more lab time.
Yep.
Whatever they want to do, I'm 100%.
Yeah, it's y'all's call. Y'all need to do it. Do test first. But we do test first. Yeah, most people like that because that way you don't have all that stuff on your mind while you're trying to do lab, which is not good. You know, playing around with 120 votes. So we'll do that. So we'll have the final exam first. And test 3 is going to be first too, by the way, guys.
And that is,
So yes, it's next Thursday. We'll do test 3 at the start of class. It's going to be timed. If you come in late, you're not going to get any extra time. And why I make sure I do test 3 so I can look it over to see if there's any problems, right, that we can go over, because we won't have a chance to go over the test before the final exam. So test 3 will be at the start of the class, and also y'all decided to do the final exam at the start of class. Everybody okay? And then after the final, so after test 3, we'll be in lab. We're through with our lectures. So we'll be in lab the rest of the day. We'll be in lab all day Tuesday. We'll be in lab Thursday after the test 3, and then we'll be lab after. We'll let y'all come to lab after the final exam. Now, lab after the final exam is optional. If you're satisfied with what you got, then that's fine.
Some of these could be through, but some of them could be in deep water.
Yeah. Okay, guys, y'all can take a break.